Hi viewers, welcome to our channel Kavithashok Educational and Motivational channel. In the previous session, permutations with repetitions are allowed. We discussed about palindrome concept. Now we will discuss the problems. Find the number of 5-letter words that can be formed using the letters of the word mixture which begin with an vowel when repetitions are allowed. We discussed the same question when the repetition is not allowed, but here repetition is allowed. So in the examination or in the competitive exams, first we have to check which type of question is given, whether the repetitions are allowed or repetitions are not allowed. So here when the repetitions are allowed, we have to solve the problem, right? What is given here? Mixture. So how many letters are there here? 1, 2, 3, 4, 5, 6, 7. 7 letters are there. In that, I is vowel, E is vowel, U is vowel. 3 vowels are there, right? 3 vowels, remaining 4 consonants. M, X, T, R. These 4 are the consonants, right? What we have to take here? The number of 5-letter words. 5 letter in the sense R is equal to 5. N is equal to 7. 7 different letters are there in the 3 vowels and 4 consonants are there, and R is equal to 5. What we have to find out here? That can be formed. 5-letter words we want. So 5 places we have to take. 5-letter word we want. The condition is here, which begin with an vowel. So we have to fill up the first place with the vowel. How many vowels are there? We have 3 vowels are there. How many places are there? Only 1 place. How many ways we can fill up? This one has 3 power 1 ways. In the previous case, when the repetition is not allowed, we will write 3p1. But here repetition is allowed. When no repetition is allowed, npr will becomes n power r. So 3 power 1. What are the vowels? It may be filled with I, or it may be filled with U, or it may be filled with E. Right. 3 power 1 ways we can fill up. Now, how many boxes are there? Remaining boxes? 4 boxes are there. Isn't it? But how many letters are there to fill? 6 letters or 7 letters? 7 letters are there. Why? Because repetition is allowed. If we fill up E here, we can use E in the next time also. Why? Because repetition is allowed. So that's why to fill up this place, how many choices are there? We have 7 choices are there. When the repetition is not allowed, if we fill the first place, we have only 6 choices. But here, repetition is allowed, 7 choices. For this also 7, for this also 7, and for this also 7. Is it clear? So, by the fundamental principle, how can we solve here? The number of 5-letter words that can be formed with using the letters of the word mixture, which begin with an vowel, is equal to 3 into 7 into 7 into 7 into 7 by fundamental theorem of multiplication. And this is nothing but 3 into 7 to the power of 4. No need to simplify. Like this we can solve the problem. If repetition is allowed, our total problem will change here. So that's why concentrate what is given in that. So finally our answer is here 3 into 7 to the power of 4. Right. These 2 problems are very important for 2 marks questions and also for competitive exams, MSET as well as mains. So listen carefully what is given. Find the number of functions from a set A with m elements to a set B with n elements. So we will solve like this here. First 2 sets are there. Number of functions we want, right? F is a function defined from A to B. Okay. A contains m elements. So we can take like this here. How many elements are there here? M elements. M number of elements. Next, set B contains n elements, right? n elements are there. Right? We can take these are the empty places and these are the elements, right? To fill up the first place, function in the sense here, a relation f from a to b is said to be a function if every element of a has an unique image in b. Unique in the sense it is related to one element, unique image in b. So to fill up the first place, we have how many choices here? N number of choices. N elements are there, na? So n number of choices are there, right? So we may relate this one, or this one, or this one. Any number we can relate, right? Now to fill up the second place, yes, may it is related to this one. That particular element also related to this one. More than two elements also related to one element here. No problem for that here. Okay, like this. If a comma b comma c are 1 2 is there, a may related to 1, b may related to 1, c may related to 1. No problem for that here. But a will not be repeated. That is wrong. So that's why to fill up this place we have n choices, and to fill up the second one also n choices, third also n choices, fourth this one and this one. Is it clear? No? So that's why the number of functions defined from a to b is equal to n into n into n into n into so on, and how many times? M times. Why? Because m blank places are there. If 2 into 2, 2 times are there, 2 square. 2 into 2 into 2, 3 times are there, 2 cube. 3 terms are there in the sense 2 cube. 2 terms are there in the sense 2 square. M terms are there here. That's why n to the power of means 2 to the power of m. N to the power of m. So this is nothing but the number of elements present in B whole to the power of the number of elements present in A. So this is the formula to find out the number of functions defined from A to B. So directly writing the formula also we can get the mark. If we understand the concept, easily we can solve the problem. If the problem is given directly by writing the formula n of b whole to the power of n of a, easily we can calculate. Look at here, and in the sense here, when the repetition is allowed, so according to the definition of function, we will solve like this here. Next, go for the second. Find the number of surjections from a set A with n elements to a set B with 2 elements, right? Again, take the function here. First of all, this is a function. Why? Because to become the surjection, first it has to become the function. A function f from A to B is said to be a surjection or onto if every element in B has at least one pre-image in A, or the range is equal to codomain. The range is equal to codomain. That means what? There is no element should be left in the set B. Is it clear now? So that's fine. Look at here. B set contains 2 elements. A set contains n number of elements. So 1, 2, 3, 4, so on. How many elements are there? N elements. In this year, for this how many choices are there to fill? 2 choices, 2 choices, 2 choices, 2 choices, 2 choices. Is it clear? So how many you get? 2 into 2 into 2 into 2, so on 2. This is how many times? N times. So that's why this is 2 to the power of n. Actually, the number of functions defined from A to B is 1. The number of functions. All the functions are not the surjections. No? Only in this, only 2 functions are only functions that is not comes under the surjection. What are that? We have to remind, separate like this here. What are that? AB function F, AB function F. What are that? All elements related to this one. And this is all elements related like this. These 2 are what? Functions, but not the surjections. Why? Because here one element is left and here one element is left. According to the definition of surjection, the range is equal to codomain. Means no elements in the B has to left remain. So, but in this case, this is left, and in this case, this is left. These two are not the surjections. In the remaining all the cases, that will become the surjections. So that's why from this we have to remain these two functions. So 2 power n minus 2, or 2 to the power of number of elements present in A minus 2. This is very important formula in case of set. So find the number of surjections from a set n elements to a set B with 2 elements is 2 to the power of n of A minus 2. In exam, just write down the formula, we can get the marks. But how can we get 2 to the power of n of A minus 2? That is important for the concept. If we know the concept, any problem is given easily, we can solve that. One more important problem. 4 marks question this one. Also for MSET. Find the number of 4-digit numbers that can be formed using the digits 1, 2, 3, 4, 5, 6 that are divisible by 2 and 3 when repetition is allowed. When the repetition is not allowed, we discussed each and everything. When the repetition is allowed, how the problem will change. So listen carefully. Right. First, how many numbers are there here? N is equal to 1, 2, 3, 4, 5, 6. So 6 numbers are there. We want 4-digit number. So R is equal to 4. So divisible by 2. We already know a number is divisible by 2 if its unit place contains even number, isn't it? A number is divisible by 2 if its unit place contains even number. Unit place contains even number. Right. First take the 4-digit number here. This is a unit place. So here this place will replace by the even number. How many even numbers are there? 2 is there, 4 is there, 6 is there. So 3 numbers are there to fill. How many ways we can fill up? 3 power 1 ways. Why? Because repetition is allowed. So instead of writing 3p1, just we will write 3 power 1. Right. Now how many numbers are there? Out of 6, one number is filled. So no problem. If it is filled also, we have the same number of elements. Why? Because repetition is allowed. So we have 6 numbers, 3 places. So how many ways we can fill up? 6 cube ways. 6 cube ways. Instead of writing 6p3, we have to write 6 cube. Is that clear? So then the number of 4-digit numbers which are divisible by 2 is equal to 3 power 1 into 6 cube, or simply we can write 3 into 6 cube. That's it. In the same manner, divisible by 3. So this is very, very, very important. Okay. Divisibility concept, right? 4-digit number, 4-digit number, right? First fill up these 3 places. How many ways we can fill up? 1, 2, 3, 4, 5, 6 numbers are there. We can fill up in 6 cube ways. We can fill up in 6 cube ways. To fill up the last place, we have one property. What is it? A number is divisible by 3 if the sum of all the digits is divisible by 3. The sum of all the digits is divisible by 3. So here how many numbers are there to fill? 3 numbers in the last. Fill up these 3 places by using 6 cube ways. The last blank place is empty. Why? Because we have to fill those number which satisfies this condition, right? In these 3 places, 6 elements are there. May the elements are filled like this here. 1, 2, 3. 3 different elements are 1, 1, 2. Means 2 same elements or 1 different element, or 1, 1, 1. 3 same elements. Or 3 different elements we can fill. Or 2 same, 1 different element is there. Or 3 same elements are there. Right. If the elements are like this here. 1 plus 2 plus 3. That is what? 3 plus 2, 5, 6. To fourth place. In the fourth place, either we can add 1. Either we can add 1 or 2, 3, 4, 5 or 6. Either we can add all these numbers. If we add 1 here, 7 we can get, 2, 8, 3, 9, 4, 10, 5, 11, 6, 12. So, sum of all the digits is divisible by 3, then the total number is divisible by 3. So, there is a choice. 3, if you take 3, it will not be divided. 8, it will not be divided. Yes, 9 is divisible. 10, no choice. 11, no choice. 12 is divisible by 3. So, this one. So, here 2 choices are there to fill the last place. One is odd choice and one is even choice. Only 2 choices. Or if you take like this here. 1 plus 1 plus 2. This is 4. To add the fourth place, we have same 1, 2, 3, 4, 5, 6 choices are there. 4 plus 1, 5, 6, 7, 8, 9 and 10. If the sum is 6, yes, sum is 9 then. So here also 2 choices are there. One is even choice and one is odd choice. And if all the 3 elements are same, to find them, this is 3 now. To fill up here, 1, 2, 3, 4, 5 choices are there. 4, 5, 6, 7 and 8. If 6 is there, it is divisible. 3 plus 1 is 4 now. How many numbers? 1, 2, 3, 4. One more number is there, 6. Then 9. So here also, if the sum of all the digits is 6 or 9, in these 2 cases it is divisible. So may we can fill up 3 or may we can fill up 6. Here also 2 choices, one is even choice and one is odd choice. Whatever it may be the numbers, 3 all numbers are different, or 2 same, 1 different and 3 same numbers, we have only 2 choices in all these cases. So we can fill up in 2 to the power of 1 ways. Is it clear now? 2 power n ways. So 6 cube into 2 numbers, 6 cube into 2 numbers are there which is divisible by 3. Is it clear now? Right. In the same manner, in competitive exams, they may ask the questions like this here. Divisible by 6 also. A number is divisible by 6 if it is divisible by both 3 and 2 and 3. So we have to check both conditions. First we will check 3. So like this we will check here. In this, one is odd choice and one is even choice. Odd choice, even choice. Odd choice, even choice. But according to the definition of divisibility, this place is only reserved for the even number. So that's why in these 2 choices, only one even number we can fill up. Is it clear now? So instead of 2 choices, we have only 1 choice. We can fill up 6 cube ways. To fill up this one, we have only 1 choice. Previously that is 2 divisible by 3. But both divisible by 6 in the sense it satisfies 3 as well as 2. So in the even and odd choice, only even choice is there to fill up. So number of numbers which are divisible by 6 is equal to 6 cube. Once you observe the pattern, divisible by 2 in the sense 6 cube into 3. 2 in the sense we got here 3. Divisible by 3 in the sense 6 cube into 2. 3 in the sense 2 we got here. Divisible by 6 in the sense just we will get 6 cube. So this is very important question in case of the competitive exam. Thank you very much.